Today we're going to look at a geometric series. Warm up. Given the series, can you fill in the following information? Is it arithmetic or geometric? And if it's arithmetic, what's the common difference? If it's geometric, what's the common ratio? So if you take a look at our first sequence, which again is a list of numbers, you'll notice that to get to the next number, if you multiply by negative 1/3 or divide by -3 every time, you will get the next term. So here it is geometric, and the common ratio, again, you can get it by taking any number and dividing by the number before it, and that should happen every time, is -1/3. So again, if you multiply each term by -1/3, you'll get the next term. Let's take a look at the next one. Is it arithmetic or geometric? And this one, if you notice, you can add 2 every time, and you'll get the next term, which makes it arithmetic, with a common difference of +2. So then we started looking at how can you take this and write it in sigma or summation notation, which means that add up all the terms. So first we're going to make our symbol for sigma. It's a funny looking E. And then we're going to say what term to start at. So here let's start at the first term. So to say that we say n equals 1, start at the first term, and add up 1, 2, 3, 4, 5 terms. So add up the first to the 5th term, and then we have to write the rule that we use to get these terms. And if it's geometric, there's 2 ways to write it. One way is we can go backwards 1. So this we would multiply 27 or -27 by -3 instead of dividing by -3. So -27 times -3. So that term would be 81, would be the 0 term. And again, we're multiplying by -1/3 every time. And n is the number of times you multiply by -1/3. So there's one way to write this, but again, we've looked at, if it's geometric, there's another way to write it. So we can say or. Again, start at the first term. But if we started at the first term, which was -27, to adjust the equation, we'll shift it right 1, and so this has to be n minus 1. So 2 ways to write this equation, which should give you the same answers in your sequence. And to find the sum, we'll just add up all the terms, the first to the 5th. So we'll take our -27 plus our 9 plus our -3 plus our 1 plus our -1/3. All right, so let's type that in really quickly. Okay, so let's escape. Okay, so we're adding up -27 plus 9 minus 3 plus 1 minus 1/3. And we get -61/3. We can leave it as the fraction or write the decimal, which is -20.3 repeating. So that would be the sum of that list of numbers, that sequence. So again, it's, what was it, -61/3 or -20.3 repeating. Double check our answers. Okay, that is correct. All right, let's take a look at, excuse me, our next example. We knew it was arithmetic. Let's write the sigma notation. So add up the first term, and there's 1, 2, 3, 4, 5, 6, 7 terms. So add up the first 7 terms, and this is linear. The y-intercept, if we went backwards 1, so subtract 2 would be -8, so -8n, or you can use x. And then it was add 2 every time. So there's the sigma notation. Write the sum using the formula. So this is what we looked at yesterday. If you have the sum of an arithmetic sequence, it is the first term, plus the last term, in this case it's the 7th term, divided, multiplied by the number of terms, and here there's 7 terms, divided by 2. So we don't double count. So if we plug in using our formula, the first term is -6, our last term is 6, times 7 divided by 2, and -6 plus 6 is 0, 0 times 7 is 0, 0 divided by 2 is 0, so the sum of all of these 7 terms would add up to 0. And you can see why. The negative 6 and the 6 would cancel, the negative 4 and 4, the negative 2 and the 2. And so you can see our sum would be 0. So to review, a sequence is your ordered list of numbers. And a series is the sum of a sequence. So again, the main words here, the sequence is your list. The series is when you add up parts of your list or your whole list. To find the sum of an arithmetic series, you can use the equation. The sum of however many terms you want is the first term, which would be a sub n, a sub 1, plus your last term times the number of terms, divide by 2. So that would give you the sum of any number of terms if you had an arithmetic sequence. But our goal today is, well, what if it's geometric? Is there a shortcut that you can use to find the sum if it's geometric? And so there's an activity that we do in class, convergent divergent geometric series, and here's the summary for that. In a geometric sequence, each term is found by multiplying the previous term by a ratio. So going to find each term, you multiply by another one. And again, here's the explicit formula. And again, there's two ways to write the explicit formula. This is if you start with the first term. If you start with the 0 term, so this should be 0. If you start with the first term, oh no, that was right. Okay. So if you start with the first term, you need to account for that with the n minus 1. If you start with the 0 term, it's just the n power. So two ways to write the explicit formula, but the partial sum, there's one formula, and that formula is this. If you take the first term, we have that right here, sorry. The first term right here times 1 minus the ratio to the n power over 1 minus the ratio. So this will give you a partial sum. It'll add up any part of a geometric series that you want to use. And so let's talk about, we have some new words today, convergent versus divergent. They're words used to describe many things, such as evolution. They can also be used to describe a series, Below is a visual representation of the definition. So if it converges, it's going to approach a point. But if it diverges, this is what you learn in evolution, then they're going to create two new things. They're going to go away from each other. And so what does that look like in a geometric sequence, which we know is exponential? If it converges, it will approach a number. So if you have 5 things and you cut that in half every time, so let's say you had a candy bar, you cut it in half every time, eventually your pieces are going to be really small and you're going to have your piece is going to be about 0, right? So this converges to 0. If it diverges, it's going to keep getting bigger, really small. And so let's say you start with 1.1 of something, you double it every time, you can see why it diverges, it's going to get really big. And so if it converges, and here's another example, it's going to approach a number, and if it diverges, it's going to keep going to infinity or negative infinity. So a convergent sequence approaches a limit, like 0. A divergent sequence does not approach a limit, so it goes to infinity, either positive or negative. What do you notice about the b value of convergent and divergent? So if it's convergent, that b value is less than 1. And if it's divergent, it's going to get really big or really small. So it's going to be a number bigger than 1, 2, 3. So here is the difference. So for convergent, if the absolute value of the b value is less than 1, it will approach a limit. And if it's divergent, if the absolute value of your scale factor, your ratio is greater than 1, it will diverge. And so tomorrow we're going to look at, well, can we add up every single number in a series? And we can if it's convergent, but not if it's divergent. But either way, we can add up part of a series, a geometric series. And again, the formula is 1 minus the ratio to the n power over 1 minus the ratio. So let's go over how it works. So the first example, find the sum of the first 4 terms of this sequence right here. The first term is 10. The ratio, take any number, divide by the one before it. So here our ratio is 3. And the number of terms, if you see ... and I'll just put number of terms, we'll eventually want the first 4 terms. So let's write the sigma notation to say add up the first 4 terms. So we'd say, all right, start with the first term, n equals 1, and we're adding up 4 of them. This is geometric, so it's exponential. So I'm going to start with the first term, 10, and it's tripling every time. But since I started with the first term, I have to shift it back to the 0 term, so n minus 1. So there's the sigma notation. And let's see here. If we want to plug into our formula now, so let's plug into this right here to find the sum. And I'll do that down here. So the sum of the first 4 terms would be the first term, 10, times 1 minus the ratio to the 4th power over 1 minus the ratio. And when you type that in your calculator, I would hit enter before I divided. Here's how I would type it in. So I would do the top first, 1 minus 3 to the 4th power. I would hit enter, divided by parentheses 1 minus 3, and all of that times the first term, which is 10. So if we added up the first 4 terms, which we can easily do because we have them listed out, but if we didn't know all the terms, you could plug in, and we could see that the sum of those first 4 terms right here is 400. Okay, let's do another example, and again, we'll practice typing it in. Example 2, 1 zombie enters the school. After 1 hour, there are 3 zombies. After 2 hours, there are 9 zombies, and so on. So if we were to list like the sequence, it's 1, 3, 9, and so on. We can see it's geometric. It says calculate the sum of the first 7 terms using the partial sums formula. All right, well, let's plug into first our sigma notation. So we want the sum of 7 hours. And again, we started with 1 zombie, and they tripled every hour. So n minus 1. Okay. Actually, for this one right here, 1 zombie enters the school. That would be a sub 0. So I don't need this n minus 1. Here would be our equation because we did have the 0 term. All right, let's plug into the sum formula. Again, recall the sum of the first 7 terms will be the first term times 1 minus the ratio to the n power over 1 minus the ratio. So here we start with 1 zombie, 1 minus 3 to the 7th power over 1 minus 3. So to type that into our calculator, again I would do 1 minus 3 to the 7th first, divided by 1 minus the ratio, and then times 1. So after 7 hours, the total number of zombies would be 1,093. Okay, so that's an example of the partial sums formula when you're looking at a geometric sequence. So now you have 2 of them to use, this new one that we learned, and then if it's arithmetic, you have the one that we learned yesterday, and then tomorrow we'll look at 1 more. So here's your second formula.